as part of the competition, there's going to be an infrared sensor, and we've got to be able to see the infrared sensor and then turn around and drop a block in a basket. But so the sensor is on a big balance, and so it's hanging on a balance here, and there's 4 baskets. And then the sensor actually hangs off the corner below one of the baskets. So our robot has to be able to drive past, see where the sensor is, and then drop the block in the appropriate basket. And if we can do that, we get a lot of extra points for the competition for being able to see that. Is what would be the best way to code for seeing something and then going back to it? Or if there's only one to see it and then respond? I mean, any ideas using like if-then, while loops? What the best way to strategize? You're constantly going back and checking.
Yeah. So when you come in, we get like a new sensor reading, and you check, which state you're in. So you have like something like if state is equal to on state. Yeah, like that. And then you have your stuff inside there, and then you read your else. State. I want to underscore here. Like that.
There's a part to the else.
Our else doesn't have a conditional part. It's
Okay, that's fine.
If it's on, else it's off. But I think we kind of
You
get.
can get the same behavior. I'm just
Yeah.
kind of using a.
I got
Oh,
you.
okay. I was like, wow.
But I guess you're doing an else, an if, and then an else if.
That's right.
Oh, okay.
And
Well,
so-
then in that case, it would have a state because it's basically it's going to check 2 conditions. So it's
Okay.
going to check this condition, else it'll check this condition, and then if this condition's not else, then there might be a third
That's
else
right.
that's not.
That's right. And so, like at the very bottom, so that's you can handle your code inside here, and then at the very bottom you have your else. Else. Okay. And then inside that else statement, I actually have a little neat trick that I use, and that is inside here. This is the oh no, something wrong's happened. So I say if the state usually define the on state to be a 1,
Yeah.
this one to be a 2,
Yeah.
and then the else would be 0 or anything else.
Okay.
Then I print out like there's some error.
Oh.
So that catches the fact that I've done something dumb in my code and not set the state to a valid state. So,
Okay.
kind of thing. So that's one trick I use.
That would be, what would it be? This is C, not Python.
Yeah, see. You can get to look like Python.
Is,
Get rid
is
of
print
these.
in C?
What's that?
Is print a command in C?
Print F. I'm really I go between languages, so I
in
just
the-
Sorry,
check.
I
in the-
just,
in the
like,
little
I'm
C
just
we
learning
have
Python, so I was just wondering.
Python. What do we use in Python for printing stuff out? Does anyone remember?
Like variables and things. So.
It might
I'm
be print. It
very
might
basics right now.
I feel bad.
Sorry.
I just keep jumping between languages, so I kind of have this, as a print statement, it's called this inside my code, and then I like, if I can't remember, I'll just go Google for it, I put it in there, and I'm like, on my way. But the big picture is you have 3 different states that you can, 2 different states you can check for, and then right here inside this state, if it's in the on state, what you're looking for is to see if you can transition back down to the off state. And so what you're looking for, so inside here you're doing it, and then the voltage,
Your coach.
Yeah, he knows I'm not going to
less than 2.
No, he knows I'm not going to be there today. He's fine with it.
So it's equal to off.
Ellen's my age at that time.
Oh, well,
That thing.
you got a free pass then.
So here you're actually, so you're looking to make sure you're in the on state. If you're in the on state, you can only transition back to the off state if your sensor value is less than 2. And then likewise, you do the same thing inside here. You kind of made a mess of things here, but really make this a little clearer. So this is just a hysteresis
Okay.
function. This is kind of like a general technique for reducing noise. And this is the same thing. Where is this used? It's like your air conditioner, your heater. does this. So if the temperature in your house goes above some certain level, it kicks on the AC. And then when the temperature comes back down, it doesn't just turn it off when it goes below that threshold level. It doesn't turn it off when it hits here. It turns it off when it goes below, say, temperature of 78 degrees. And then when it goes, temperature goes back up, it doesn't turn it back on when it goes above 78. It turns it back on when it goes above 80 or something. You can set that delta in your thermostat, have a little switch that says how big this zone is. That's what that little extra thing is. If you go home, look at your thermostat, there'll be a little option in there, probably if it's digital.
We do Poe for that.
So that's one way to get rid of the noise.
Okay,
That's
so just to kind of recap, it's say I have a threshold, I want it to come on if it peaks over an input value of 50.
Uh-huh. Yep.
So I would say if the sensor is greater than 50, I see it program.
Yeah.
But I don't stop running my if I see it, I run my I saw it program. Else I haven't seen it yet. So how would that?
Well, what I think we're describing is just a set of states. So what we have here is what we call the on state,
Yeah.
and here's what we call the off state.
Right.
And you have to define how you move between states.
Okay.
So this is something you can use in your code. This is kind of a standard state-based diagram kind of thing. So how do we get from on to off? Well, if we want to go from the on state to the off state, we have to have a voltage that's less than 2. So that's sensor.
So
This is
that
another way of describing it. How do we go from off to on? Input sensor is greater than
4.
Yeah, that's it. So this is like a much better way of describing this, because this is code. This is just a state diagram. So what you're describing is maybe you have different states you can be in. I'm in this state or that state, or oh my God, I've driven too far kind of state kind of thing. You can make states for each one of these things and figure out under what conditions you'll translate between the states. We'll just call this a function. We'll call this update state. And you have to translate this into your language of choice. So what you're talking about is you got this function, and you can just call this function that then updates your states. So you call that somewhere in your code.
Okay.
Now we're just going to pull that out. So we're going to abstract that away.
Oh, okay. Yeah.
And there's our function call. And then like you were talking about, if, now with this, now we got like this hierarchy of, rules that says, hey, if this condition is true, like everything's cool, like we haven't gone too far without seeing what we're looking for, then just update your states like you normally do. Or maybe you need to drop out of this and do something special. And that would be like an exceptional state, like something I didn't expect to happen here. But you got to handle all those cases. That's the thing. Hey, maybe these states in the system look like, the search for, what is it, the beacon thing? That's that state. And then how do we get into the, drop, just breathing, drop the block in the bucket state. And so you can kind of see how we can transition between these different places, and under certain conditions we go to different places.
Yeah. So
You kind of organize it and
that is a good idea. That
Kinda
is a
like-
good idea
That's a really good
because
way
first
to
we're gonna
figure
have
things
to we'd have to have a move to start.
Yep.
And then once we move to start, we have to transition into search for block. Once we find a block, we're going to have to drop the block. All right. So then, how would you write this? What if we moved into search for block, but we never transitioned? So how would you draw that?
well,
we never saw the beacon in order to move
You
to
would
drop to
just
block.
have
So
it
we'd
loop
still be in
the
the search
search.
for block. So how would
Yeah.
you represent what to do?
yeah, you're kind of in the state where you're just continually searching for a block then.
Yeah, and that's when you get your print error, and like I said, you would drop back down here into something else,
And maybe there's another.
then come back in and drop the block.
Oh, that
So,
would be.
saying you come back
Okay,
past
so-
here.
So maybe like reset search.
Right,
Um,
which in turn, that might tell you just to go backwards to find.
reset search to search for block. To go
Maybe
back.
there's another state in between there
Yeah.
also, right? You gotta do something special.
Well, after we drop the block, we actually have to go park on the ramp. This is
Yeah.
actually a ramp.
Okay,
And so when we're done, we have to go park on the ramp
yeah, so then that becomes another behavior that you gotta kick off.
Color sensor.
Park ramp.
Yay. Yeah, we're planning on using a color sensor for that one.
Cool. And how you organize it's kind of up to you. This just kind of helps you like try to make sense of all your code because you end up with this big, massive collection of if-else nested things, and trying to keep a handle on it. Because if you can find, okay, so this is kind of abstract, but what we're trying to do is create some representation of this.
Right.
That's easier for us to wrap our minds around, look at, and talk about.
Yeah.
So then we could go back to the code and go, does it actually do that?
So this is where like the variables that we learned about would be good.
The int.
Because we could, well, the void.
Void,
the
not,
void
yeah,
variable.
void, not
So if
int.
we made variables for these different operations, and then, so you kind of, so you break it down, be like, all right, so here's the code to do this one thing, and we store that as a void variable.
Yep.
And then then we just call it in the order that we need.
Yes.
And it's organized somewhere else, that way we're not looking at some big massive thing.
Yes.
It's hard to get our head around.
So you can